Welcome! Today we're going to talk about what to do when you need to involve more than one step of stoichiometry calculations to solve a problem. Sometimes your path will not be direct. You need to go through a couple of different steps using different either mass to mole conversions, mole to mole conversions, or mole to mass conversions, and that's what we're going to do today. So we are going to take a look at a reaction that forms a precipitate. So if you recall, a precipitate is a solid that's formed when two aqueous solutions combine and react together. So it looks a little bit like this. The white swirl in the middle, that's the solid precipitate, and it's in a clear solution, most likely an aqueous solution. So in this example, we are going to look at the reaction between NaCl and AgNO3, or sodium chloride and silver nitrate. These two aqueous solutions are combined together in that test tube, and it forms sodium nitrate and a silver chloride precipitate. So silver chloride is the white precipitate cloud that you see in the clear aqueous solution. So it looks as though just looking at the chemical equation, we see that 1 mole of sodium chloride reacts with 1 mole of silver nitrate to form 1 mole of sodium nitrate and 1 mole of silver chloride. So everything there is 1 to 1 to 1 to 1. So here's the problem that we're presented with. If we react 250 grams of silver nitrate, or AgNO3, how many grams of silver chloride precipitate will be produced, or AgCl? So the way that I like to start out my problems is by writing down what we know and writing down what we want to know. So in this case, we're given that there are 250 grams of silver nitrate, or AgNO3, and we want to find out how many, or X, grams of silver chloride. So how do we go from the mass of one to the mass of another? Because we can't convert directly between the two. We don't have a ratio for the mass of silver nitrate and the mass of silver chloride in our formula. We only know the moles, the mole ratios from this formula, or this chemical reaction equation. So let's see what our first step will be. I would say that the first step would be to calculate the gram formula masses, or the molecular weight, for both compounds that we're talking about, so the silver nitrate and the silver chloride solution. This will also buy us time to figure out what our next step will be. So we are going to calculate first the gram formula mass for silver nitrate, and I will give you a moment to write down that calculation. So in our silver nitrate, we have 1 atom of silver, and the silver has a gram formula mass of 108 grams per mole. So that's what we'll start out with, the silver, 108 grams per mole. And then we'll add that to the gram formula mass for our 1 nitrogen, which is 14 grams per mole. And then what's left is our 3 oxygen, and we have 3 times the gram formula mass of oxygen, which is 16 grams per mole. So if we take a look at all of our numbers that we're adding together, they all have the same unit of gram per mole, so that's excellent. We'll keep that unit in our final answer. I'll give you a moment to calculate. So using my calculator, I got a gram formula mass of 170 grams per mole for the silver nitrate. And Now let's follow the same process to calculate the gram formula mass of silver chloride. I'll give you a moment to write down the equation. In the silver chloride, we only have to take into account the gram formula mass for two elements, the silver and the chlorine. So this one's a little bit easier. But I had 108 grams per mole for my silver, plus 35 grams per mole for the chlorine, and that totaled to be 143 grams per mole for the silver chloride. So now we're done with step 1. So now we have the mass of the silver nitrate reactant, 250 grams, and we have the gram formula masses for both silver nitrate and silver chloride. So step 2, if you haven't already guessed, is to calculate the moles of silver nitrate that reacted in the double displacement reaction that we have here. So we know that we have the mass, and we want to convert to moles. So this is going to be a mass to mole conversion. So I usually start out by using what I know, that we have 250 grams of silver nitrate. And since we just calculated the gram formula mass, we can use that as a conversion factor in our equation. But we do have to flip over that conversion factor because we want our proper units to cancel out. So instead of 170 grams per mole, it will be 1 mole per 170 grams. We just flipped that over. So now if we multiply, we can actually cancel out the unit. And you guessed it, we can cancel out the unit of grams. So our final answer will be in moles of silver nitrate. So I calculated this to be about 1.5 moles of silver nitrate as my answer. And this is actually where I'm going to stop part 1 of this video. I'm going to continue on with the next 2 steps in the next video, but this will give you a little break and you can take that time to think about where we're going next. So right now we have moles of silver nitrate, but we still want to find out the mass of the silver chloride that we are producing. So I want you to think about that brainstorm and think about how we can get from our moles of silver nitrate all the way to finding out the mass of the silver chloride that's produced in the reaction. Alright, I will see you soon in the next video.